So on behalf of PTC, thank you for joining. This is an exciting speech. I'd like to talk about which emerging technologies are changing legacy subsea systems. To give you some background, essentially, subsea systems have evolved tremendously over the past decade, changing optics, delivery, and indeed economics. What does this mean for legacy subsea systems? And the cables have been deployed in the water for many, many years. So this lightning talk explains how we deal with legacy systems and how we move forward. I have 3 questions for Steve. So if I may kick off. Steve, what has been the biggest technology change on legacy networks you have seen?
So Keith, I think the single biggest change has been the introduction of coherent detection, coherent optical communications. Came into the industry around 2010. Ciena was fortunate to be the first to bring this technology to market. But what coherent means is we're using one laser to measure another, and we can dramatically increase capacity on a cable. And in fact, we can go on to an existing legacy cable, one that was, in the past lovingly crafted with different slopes of dispersion compensation and pulse shaping, and you do a lot to kind of marry the submarine lightwave terminating equipment together with the cable under the water. We can actually take off that old submarine terminating equipment, put new equipment on it, and in many cases increase capacity factors of 2, 3, 4. We've got some examples even where you've been able to get 10 times the capacity on that exact same cable, because we can solve all the propagation equations with math. We use digital signal processing inside of these new terminals, and that gives us the ability to dramatically increase capacity.
Thank you, Steve. Okay, are there any new technologies being worked on which will impact the existing legacy subsea systems, and how do you see that affecting them?
Absolutely there are. So we're on our 5th generation of this coherent technology. We call it WaveLogic 5. It's targeting at an 800 gig total maximum capacity on an individual wavelength. Now, a lot of legacy systems wouldn't support that, but the point of these new chips is every rate actually gets better. The receivers perform better, the transmitters perform better, and we've built a number of technologies into the most recent digital signal processing chips. Some technologies are called probabilistic constellation shaping, where we have this constellation of signals that we generate that's what's actually propagating, and we can shape it according to the nonlinear properties on the cable. So we're adding more and more intelligence into the actual DSPs, and that allows us to continue to upgrade the legacy cables.
Thank you, Steve. I have one final question to wrap up. What else do you see as having an impact on legacy systems at large?
Well, I think the next couple of steps are going to be around adding additional intelligence, going back into further automating. A lot of these systems still are considered fairly static. We may not be monitoring everything that we want. Some of the legacy OAM&P systems that are sitting, the surveillance systems, there's still a lot of work that can be done to harvest out the cost of maintaining and operating them by automating a lot of the processes and the deployment models and the operational models that we go through. So application programming interfaces, analytics, building in machine learning capabilities into the actual operating model, we think makes a huge difference.
Steve, thank you very much. I'd like to thank you all for joining on behalf of PTC. It's available on PTC TV, Ciena blogs, and indeed Equinix blogs. Thank you very much, Stephen.
Thank you.